Are you all at page 197? Everyone good? Anyone not? Good? Happy? Cheerful? Good. Sid, you got it? Got it. Cool. All right. So we are going to go through solving a system of equations, which means we are graphing. A system of equations could be a whole bunch of equations all graphed at once, but we're going to graph two lines. So two lines can cross each other once, or they can be parallel, or it could be the exact same line that lies on top of itself. So there's three different scenarios that could take place. So we could have two lines that cross each other, we could have two lines that are parallel, or we could have two lines that are right on top of each other. It helps when I have a different color. Okay, so those are the three things that we can deal with, and this all has to do with how many solutions that our system has. So we're going back to graphing. Let's see, graph. Okay, so graphing is the first one. So let's see, the very top of your page on page 197, we want to graph, I'll do these in two different colors. We want to graph this. So friends, what is my y-intercept of that line? 1 is, so 0, 1 is right here. And what is the slope of that line? 3 over 1. So from this point, I'm going to go up 1, 2, 3, right 1. I'm then going to use my straight edge and draw my line the best I can. Okay. Does that feel comfortable so far? Yes. Cool. Then let's do this other one. Let's do it in, I don't know, I want that. Yeah, that's the color I want. I like the pink. All right, so take a look at this one. This one is set up to graph it which way? Say it. Cover method. Cover method, yeah. X and Y are on the same side. So 0, blank, blank, 0. All right, so I'll demonstrate on this board. So this is an X value here. So if I cover this up, Y equals what? 6. Okay, so that's the first one. So 0, 6. All right, and then this 0 here is a Y value. So 2 times what number gives me 6? 3. So this gets me my X and my Y intercepts. All right, so 3, 0 is 1, or see, 3, 0 is 1, 2, 3 is right over here. And then 0, 6, 0, 1, 2, 3, 4, 5, 6. So we have that. And I draw my line of best fit with my pink. I got lucky getting it relatively straight. Do you all feel comfortable that these two lines cross each other? Okay? Agree? Now, if you graphed it and you used a straight edge on a piece of grid paper, you would probably be able to say, hey, these lines cross. So it appears they cross at 1, 1, 2, 3, 4. So 1, 4 is where they cross each other. So that is the solution to this system of equations. Okay, so a solution can be a point. I'm pretty sure almost everybody has some sort of cell phone. Agree? I'm pretty sure on your cell phone you have some sort of capability of locking your screen so you be the user unless somebody knows your access code or has your fingerprint or has your same face. Okay? The thought process behind this math is the same thought process that the computer algorithm that Apple or Android or whoever your cell phone provider is does. It's looking what basically your fingerprint or your access code or your face is the solution. So it plugs the solution into a system of equations, and if it's true on the system of equations, meaning that's where they would cross, that's how it knows to unlock. I kid you not, that is the math behind it. Okay, yes, it is computer programming, but computer programming goes very well with stuff. So this happened to be one where our points crossed one time. That means we have one solution. The entire point, the x and the y value, are both needed for the solution. Okay? Can I move on? All right, so this is my next one. What does it appear my y-intercept would be on this particular? 5. Yeah, so I'm going to go up 1, 2, 3, 4, 5, put a dot. What's my slope? 1 over 1, so up 1, right 1. Okay, that's what the first line does. Let's look at the second one. What does it appear the y-intercept would be there?
1. 0.
0, yeah. Because I could rewrite this to look like this. Because there was nothing there, so I'm going to put nothing there. And then my slope is what? Bless you. What's my slope?
-4.
Okay, so I'm going to go down 4 from that purple dot. Down 4, right 1. So if I graph this as neat and tidy as I could, I would say that this right here is our solution. If I had graphed it, if I had used my straight edge, I think this is where they cross. Okay, now, they don't always have to cross at exact values, but in this class when we're graphing them, they should cross at an exact point. So I believe, because I had a little bit of error on mine, I believe it should be 1, 3. Maybe. Let's see. 1, 3 going to work? No, I think it's actually 1, 4. I think it is up a little bit. I think it should be 1, 4. Yep, 1, or -1, -1, -1, -1. Dude, I tell you can't take me anywhere. Yep, 1, 4 is the solution. So -1, 4. So how I know this is the solution is take a look at this. If I take my first equation, which is this, and I plug my x and y value into the equation, I get 4, which is the y, equals x, which is -1, plus 5. That means 4 equals 4. That works. If I take my other equation and I plug my x and y into it, I get 4 equals -4 times -1, which is 4 equals 4. So notice I get 2 true solutions. That doesn't mean I have infinite solutions. That just means that my point plugged in to give me a true solution on each one. That verifies my, when I graph it to work. Friends, do you have questions for me so far? All right. We ready, Freddie, Betty, and Eddie? So what are you looking for? You are looking for a point. Okay, you're looking for a point. So let's take a look. This one, they don't want us to graph it. They just want to know if this point is a solution. So we have to know that this is x, this is y, and we're going to plug both of them into our graphs, or our equations. So my y value is -3 equals -2 times my x value being 4, and then I'm going to add that last 5. And if this works, this is a solution for something costs $8. I have $5 in my pocket. How much do I owe? Something costs $8. I have $5 in my pocket. How much do I owe? 3. Okay, so this works. So I'm going to do the same thing down here. I'm going to plug my x value in, and I'm going to plug my y value in. So I get 2 times -3 is -6. So I have $4 in my pocket. Something costs $6. That gives me another true statement. So is this the solution? Yes. This is the solution to the equations. Yep. Because it gave me a true statement on both. Gave me true here, gave me true here. Once I plug my x and y values in, I replaced x and y with my x, y value. my point, my solution that we're checking. Okay? So let's try this one. XY value. Agree? All right, so I'm going to plug in here. So I'm going to get 3 times, what's my X value?
1.
1. My Y value is 5, so minus 5 equals negative 2. So 3 minus 5 equals negative 2. So negative 2 equals negative 2. Does that work? So it works on the first one. Let's see if it'll work on the second one. What's my Y value? 5. So 5 equals 2 times 1 minus 3. 5 equals 2 minus 3. 5 equals negative 1. Is 5 equal to negative 1? So this is not the solution. You have to check it on both of them. It's very possible one will work and the second won't. It's possible that the second won't work and the first will. Okay, so be cautious. So if you found that the first one didn't work, you're done. You just say, it doesn't work, nope, it's not a solution. If the first one worked and the second one didn't, but you didn't show the work to show that the second one didn't. Okay? So we are just graphing. So how many solutions does something have? So I'm going to move this out of the way. So this first graph crosses one time. This right here is a point, x comma y. It's where they cross. This has one solution. This is the one location where that point is on both my red and my blue lines. The second one, if we had graphed it, oops, get out of there. Move you down there. All right. My second one, if we had graphed it, it shows the lines are parallel. And what did we learn back in elementary school about parallel lines? What? They don't intersect. They don't cross. This means you have no solution. Okay, parallel lines don't cross. If they don't cross, we don't have a solution. Okay, and my third scenario is if I try and graph it, notice I only have one line. That means if I had graphed this, it is the same line. So these two different equations that I graphed give me the same line. This means we have infinite solutions. Okay? So I know we're done with the notes, but I want to just do a little bit extra. Can I move off this screen? Okay. All right. So when graphing, we have 3 different ways that we could have it written. We could have y equals mx plus b. So b is the y-intercept. M is the slope. So if I had y equals 2/3 x minus 5, I would have 0, negative 5 being my y-intercept and 2/3 being my slope. Okay, so that's the first thing we do. We also might come across an equation that looks like this, where a, b, and c are numbers, and this is done by the cover method. So you use 0, comma, blank, blank, comma, 0, just as a reminder. So if I add 2x minus 3y equals 12, and I add 0, comma, blank, and blank, comma, 0, so that's an x value. So negative 3 times what number gives me positive 12? That'd be negative 4. Negative 3 times negative 4 is positive 12. This is a y value. 2 times what number gives me 12? So 2 times 6 gives me 12. So cover method works really nicely. And the one that we don't use all that often is when it's set up like this. Okay, where you plot the point x1 comma y1, and then you use the slope. So an example of this might be y plus 3 equals 7 over 8 x minus 2. This would yield me the point 2, 3. Notice they are opposite, 2, negative 3. They're opposite signs. And then I have a slope of 7/8. So once you plot that point, then you use the slope to find an additional one. All right, so this is relatively new as far as graphing two things and finding where they cross. But what I would like us to do, what time are we out here? 11. All right, I want us to work on page 199 only. I want you working on it in class. That way you can ask us about it and we can do it. So that's basically problems 1 through 7. Okay? If you're not working on it in class, then maybe you're going to be in trouble. Stone's got something up her sleeve. She'll toss you. Where'd Stone go? Oh, there she is.